Today we're going to look at 1-3, which this section is going to be on solving equations with variables on both sides of the equal sign. So in 1-2, we looked at solving equations with one variable on one side, and now we're going to look at equations with the same variable on both sides. So the nice thing about equations with variables on both sides is that you can use properties of equality to solve an equation with variables on both sides. Equations can have one solution, infinitely many solutions, or no solution. So in this video, we're going to go over when can you get infinitely many, when can you get no solution, and when can you have one solution. So infinitely many solutions occurs when the equation is an identity, okay? An identity is an equation for which every number is a solution. So that means if I plug in -1, I get it. The equation works out. If I plug in 20, the equation works out. If I plug in 100, the equation works out, and so on and so forth. So you usually can tell an identity by how each side of the equal sign looks. So let's look at 28. In 28, we can see that we've got 2c plus 3 equals 2c plus 3. So automatically I see both sides, left and right, are exactly the same. However, I just want to make sure. So what I'm going to do is I'm going to try to combine like terms on each side of the equal sign. So I'm going to subtract 3 from each side. When I do that, I get 2c equals 2c. So now I can really see that they have to be equal to each other. So for any value of c, the equation is true. Right? And so we can check that. If I plug in, let's say c equals 1, then I get 2 times 1 equals 2 times 1. So 2 must be equal to 2. Yep. And then let's try a negative number. So c equals -2. That's going to be 2 times -2 equals 2 times -2. So that's -4 equals -4. Those are also equal, and I could keep checking. So any value of c is going to make 2c equal 2c. So therefore, this is an identity, and therefore must have infinitely many solutions. Okay? Now let's look at no solution. So no solution occurs when no numerical value makes the two sides of the equation equal. All right? So this one's not going to be as easy as the identity, because identity I can kind of look at the equation and say, oh, they're the same, right? However, with no solution, I have to solve. So I have in 34, 5 times quantity 5t plus 1 equals 25t minus 7. And I want to try and solve for t if I can. So what I'm going to do first is I'm going to distribute the 5 on the left-hand side to the 5t and the 1. So I get 25t plus 5 equals 25t minus 7. From here, I'm going to combine like terms. So first thing I'm going to do is I'm going to subtract 5 from both sides. I get 25t equals 25t minus 12. I also want to get t on the other side of the equal sign. I don't want to work with it on both sides. I want it just on one side. So now what I'm going to do is I'm going to take 25t and 25t minus 12, and I'm going to subtract 25t from both sides. When I do this, the 25t on the left-hand side cancels out and becomes 0, and the 25t on the right-hand side cancels out and becomes 0. So now I have 0 equals 12. However, 0 can never equal 12, no matter what I plug in, so therefore there must be no solution. Okay? And then the last one we have to look at is the case where we get exactly one solution. So one solution occurs when the equation is not an identity and has exactly one numerical value. That makes the equation true. So what we want to look for is we want to solve for x, or whatever variable we have, to get one exact solution that makes both sides equal to each other. So in 24, I have 3 times quantity of x minus 2 equals 9x. I'm going to distribute the 3 to the x and the 2. So I get 3x minus 6 equals 9x. I want to get the x by itself on one side and everything else on the other. So I'm going to subtract 3x from both sides. I get negative 6 equals 6x. And now that I have my x on one side and my negative 6 on the other, it's going to be just like what we did in 1, 2. So we're going to try and isolate x by dividing both sides by 6. So we get x must be equal to negative 1. And so notice we get exactly one solution. To make sure it works, we'll do a quick check. So we'll plug in negative 1 back into the original. So 3 times negative 1 minus 2 equals 9 times negative 1. This is 3 times negative 3 equals negative 9. Negative 9 equals negative 9. So yes, negative 1 is the solution. In 36, it's a little bit more of a complicated equation, but again, we want to see if we get one solution, no solution, or infinitely many. So first thing I'm going to do is I'm going to multiply both sides by 4, because again, I have that 1/4 in front and I want to deal with that first. So that cancels out and I'm left with 2 times x minus 1 plus 10 equals 4x. Now I'm going to distribute the 2 to the x and then minus 1, and I get 2x minus 2 plus 10 equals 4x. From here, I'm going to combine like terms on the left. So I get 2x plus 8 equals 4x. I want to get everything with the variable on one side, so I'm going to subtract 2x from both sides. I get 8 equals 2x, so x must be 4. Again, I want to check to make sure that's actually the answer. So I'm going to plug this back into the original. So I have 1/4 times 2 times 4 minus 1 plus 10 equals 4. So now I'm going to take care of the middle parentheses that has 4 minus 1 in it. So that's going to be 1/4 times 2 times 3 plus 10 equals 4. I'm going to multiply the 2 and the 3, so I get 6 plus 10 inside the parentheses. I'm going to add those together, so I get 1/4 times 16 must be 4. And 16 divided by 4 is 4, so 4 equals 4. So that is the solution. So the last example we're going to do is applying our new knowledge of solving equations with variables on both sides to word problems. So in the last section we did word problems, but they only had a variable on one side of the equal sign. In this one we're going to see it on both sides. So it says Cameron pays 95 cents per song with his current music service. His friend tells him of another service that has a $15 joining fee but charges 80 cents per song. At what number of songs does this new device become a less expensive option than Cameron's current service? So I'm going to draw a chart again because I find those useful. So we have his current service and this new service his friend is telling him about. Per song, the current service charges Cameron 95 cents. Per song, the new one would cost him 80 cents. A new joining fee would be $0 with the current service, but would be $15 additional with the new service. So if we say that x is the variable of songs, so the number of songs, we can say that 0.95 times x plus 0 must be the total cost for Cameron, and 0.80x plus 15 must be the total cost if he went to the new service. And we want to see at what point, at what number of songs does this new service become a less expensive option than Cameron's current service. So we're going to set the current total price equal to the new total price and solve for x. So we're going to do 0.95x plus 0 equals 0.80x plus 15. So what I'm going to do first is I'm going to subtract 0.80x from each side so I can get the x all on one side. So this becomes 0.15x equals 15. I'm then going to isolate the x by dividing both sides by 0.15, which ends up being 100 songs. So what this means, what we just did is we found that at 100 songs, the price is the same. But we didn't want to know when was the price the same. We wanted to know when will the price be less with the new service. So that means at 101 songs, the new service will cost less. And the reason why is because at 101 songs, it's going to be a little bit cheaper to pay for that last song after the 100th one. So our answer is 101 songs. And that's it for 1-3. So the homework for 1-3 will be on page 21 in the book. Numbers 5, 7, 11, and 15 to 41 odd. This will be due at the end of the class period. On Monday. And I will see you in class.